Okay, so that was the theory for permutations. Now we're gonna do some examples. And when questions come up, feel free to pause the video, have a go at the questions yourself, and then unpause the video and I'll show you the final answers and I'll work through each of the questions as well. So feel free to pause the video here if you like. Alright, so here are the final answers. We're going to go through the working out. Okay, so without repetitions, we're going to try to form a sequence of letters, 3 letters, from choosing 6 available letters from the word Sunday. So we're going to draw up 3 slots representing the 3 letters we're going to choose. Right in the beginning, there are 6 options, right? All 6 options are available to us, but there's no repetitions. So suddenly when you make your second choice, there's only 5 available. And then 4 for the third choice. Multiplying that together, we get 120. So for a simple question like this, I definitely recommend drawing a simple diagram like this and just crunch the numbers in this manner. You don't have to do anything fancy. But of course, if you really want, you can do the permutation formula, right? After all, we're just doing 6p3. There's no repetitions and order is definitely important. So it's a permutation. And so we can use the permutation formula. And 6p3, of course, gives us the same answer. Okay, so this theory for question 2, this theory tells us that if you want to rearrange or shuffle n objects, the answer is just n factorial. So this question is just asking how many ways can we shuffle all 6 letters of the word Sunday. Okay, so that's just 6 factorial, giving us the answer straight away. Question 3, we're forming a license plate and it's made of 6 characters. So here are the 6 characters. Of course, repetitions are allowed, and of course, order is important. And for the first 3 letters, we got 26 available options. And then we got 10 digits for the next 2. And then we're back to a letter at the end. Okay, next set of questions. Alright, question 4. We're trying to make these 10-digit numbers, but just make note that you cannot start a number with the 0 digit itself. And in part A, we're gonna do so, but assuming that you can only use each digit once only. So right in the beginning, you got 9 options to choose from. Normally they're 10 digits, but again, you cannot use 0, so we lose 1 availability. So you only got 9 to choose from. Okay, what about the second choice? Let's say back in the first choice, let's say you have chosen to use the digit 1. But when you go back to using your second choice, you lose the ability to choose 1 because you already used it up. But then the digit 0 is back on the table, so therefore you got 0, and then the digits 2 onwards. So that gives you 9 options. And then after that, you do lose another option. So you got 8 now, and then 7, and so on. All the way down to 1. So that's the answer, but you can see that you can write this more compactly. Notice how this tail bit, this is just 9 times this, but this bit in the tail is just 9 factorial, right? Okay, same question about part B. Okay, same thing at the start, you only got 9 digits to choose from, no zeros. But then when you go for your subsequent choices, you always have your 10 digits available as options to you all the time, right? And you got to make 9 of those choices. So 10 choices, do that 9 times. So this is the answer. Okay, so next one, we're handing out some prizes. First, second, and third, but assuming no equal ranks. Okay, so maybe in these questions, it's really useful to imagine the scenario, right? So you got 10 students standing in front of you, okay? And you're trying to hand out 3 award certificates. So let's say you're holding the certificate for coming first in front of you in your hands right now. And how many ways can you give that certificate to the students standing in front of you? There are 10 ways, right? The 10 students standing in front of you, you could choose to give the certificate to any one of them. So right in the beginning, there are 10 choices. Okay, now you go back, you're going to get the certificate for the second prize. So you cannot give that certificate again to the same person, right? So therefore, you lose the choice. Or you can think of it as like the student who got the first prize, you can remove him from the stage, right? So now there's only 9 students that you can choose from to give the second prize. And a similar argument for the third prize. So 720. Okay, question 6 is really a very similar scenario, but except now the prizes are subjects. So now you can always repeatedly give the same kid the same multiple prizes, basically, because you can get the maths and the physics prize. Okay, so again, imagine you got 10 students standing in front of you. You got your initial maths prize, right? And you're trying to give it to one of them. So right in the beginning, you got 10 choices. Okay, but now you're gonna make all the students still stand on stage, right? No one's moving off. And then now you're gonna go get the physics prize. And how many options can you give that physics prize out? Again, you can give it to any one of the 10 kids, right? So you got 10 options. And the same thing for the last prize. So altogether, you got 1,000 ways of doing this prize handout. Okay, next question. Alright, so we got a 3-digit number is to be formed from these 6 available choices. And how many of these numbers can be formed? Assuming that there's no repetitions at all in this whole question. And let's begin with no further restrictions. Okay, that one should be simple. So 6 by 5 by 4. It's about B. So we want to try to ensure that the number has to be odd. Well, here's our 3-digit number, right, that we're going to come to. So what makes a number odd is just whether or not the last digit is odd or even. That's what controls whether the overall number is even or odd, okay? So if you want to ensure that the number is odd, just focus on the last digit initially. Okay, so let's build this last digit. So you got this 6 available choices to make. Here are the 3 available options to make this last digit odd. So there are 3 options there. So let's say for this option, you have chosen to use the digit 1. And then you're trying to build the rest of this number, right? So, and this is all that's needed to make sure this overall number is odd. So really, you have complete freedom in these 2 numbers. They can really be any type of number, okay? But there's no repetition, so you used up 1, so it's gone. So when you're trying to go to build the first digit, how many options do you have? You got these 5 numbers to choose from. Okay, so there are 5 options. So out of these 5 options for this first initial digit, let's pretend you've chosen 2. So now again, it's gone, no repetitions. So for your middle choice, you're down to 4 options only. So altogether, we have 60 ways of doing so. Okay, so really, for this whole entire topic, maybe the most important thing you should learn and pick up along the way is actually these problem-solving strategies, okay? So just with these simple examples we've seen so far, we already demonstrated one strategy, okay? And that's just drawing these simple diagrams, these slot diagrams, or draw up all the options and cross them off. Little things like that can help you keep track of things and count things, and that's really handy. And you should definitely always try to draw some kind of diagram to help you answer these questions. Very useful strategy. So if you look at the answer in part B and also the answer part A, you might notice something suspicious, and that is the answer in part B is just half of part A. So it's just half of the grand total. So it turns out we can also answer B through a different way. We can simply just argue what the answer should be through this piece of logic. And basically, we got the same amount of odd digits and even digits. So if they're the same amount, then there's equal probability that the number is even or odd. So therefore, it must be half of half, right? Half of all the grand total must be odd numbers, and the other half must be even. And there are in total 120 possibilities. So naturally, half of them are odd. So this demonstrates another problem solving strategy that we can use, and you can search for a logical argument that we can use to just get at the answer. And this problem strategy is sometimes hard to see, and it really just comes with experience. But I can give 2 prompts to maybe help you see this. And a lot of the tough questions, they usually have some kind of symmetry behind them. So the symmetry behind this question is simply the fact that we have the same amount of odd digits and even digits to work with. Like if this question were done on digits just from 1 to 5, then this whole argument would go out the window and it wouldn't work. So this whole argument really relies on the symmetry of the problem. And another way to see these logical arguments sometimes is to just simply look at questions from a different perspective. As we go on to do harder questions, we'll see more examples of utilizing this strategy. Okay, next part. We're going to try to search for numbers that's greater than 230. Hopefully when you thought about this question, you realize that there's sort of 2 categories of answers that's able, 2 categories of numbers that's able to satisfy this being bigger than 230. So basically there are numbers that starts with a starting digit of 3 or 4 or 5 or 6. These numbers are obviously automatically bigger than 230, right? And there are also numbers that starts with 2, but not all of them, only the ones that goes with at least 2, 3, right? So you can't go with 2, 1, that would be lower than 230. So basically these 2 categories, if you start with 3, 4, 5 or 6, this guarantees you're greater. And only certain numbers starting with 2 will work. So what you can see is that these 2 groups of answers, they sort of have different conditions behind them. So what this suggests is that you should perform these 2 counts. Count how many possibilities there are in these 2 groups, but count them separately. You break this question into parts and do it by parts. So we're going to count case 1 first. We're under the scenario where we're building numbers that starts with 3, 4, 5, or 6. Okay, so the first digit, we have to go with this case, right? So there are 4 options. We can make use of these 4 digits. So there are 4 options. Let's pretend you used up 3. Now, as soon as you start with 3, any of these remaining digits will work, right? Like the overall number will definitely be greater than 230. So all these numbers, or the numbers remaining, we can free to use any of them. So therefore there are 5 choices. Okay, so let's say when you made your second choice, you used up 1, let's say. So now you got 4 remaining digits, 4 options for the last bit. We come to a count of 80 for this case. And we simply move on and count the total in the second case here. Here we have to start with 2. We're insisting that the number is starting with 2, right? So there's only that initial 1 choice. We insist that you start with 2. Okay, so when you go for your second digit, there's no repetition, so the 2 is gone, it's already used up. Okay, so, but remember, we're trying to build a number that's still greater than 230. So therefore, at this stage, you cannot use the 1. So when you try to fulfill the second spot, there are 4 availabilities, 4 choices. And let's say when you try to fulfill this middle bit, you've chosen to use 3, so 3 is gone. Now you got to be careful when we try to fill out the last bit. This 1 could not be used as the second digit, but it certainly can be used right now because, like for example, the number 231 will work. So when you consider this last option, this 1 is sort of back on the menu. Okay, so with that said, you got 4 options remaining for the last slot. So 16 over there. Across the 2 cases, now we can fully answer the question. and you add the numbers from these two cases. So altogether, there are 96 numbers greater than 230. Okay, so this example illustrates really important problem solving strategy. Sometimes you have to break the question into cases and do them separately by the cases. Okay, so with part D, I'm actually going to do this question with a mistake to illustrate a common mistake that people do. Okay, so we're trying to build a number that's less than 230. So some people might go, okay, we're trying to make the number small, so we definitely got to start with these two digits. So we got two choices for our first slot, two choices. Let's say you've chosen to use 2. So now for your the middle slot, we have 5 available numbers. So here's our 5 options. Let's say you used up 1 for that choice. So now you're left with 4. This comes to an answer of 40, and of course this 40 is just totally wrong, okay? So let's see why that is. Let's go back. And the mistake basically happens exactly when we said this was 5. Remember, we're trying to make a number that's less than 230. So you can see that when you say at this point, when trying to fill this middle number out, you can see that if you say there are 5 available options, you're wrong, because that would include numbers like 2 and then having a 4, or in fact 2 and then 3, and then the last digit could be 1. So you're getting that number like 231, which is certainly not less than 230. So basically this way that we have counted has included numbers like 2, 3, 4, okay? So basically we had this issue because only certain numbers work with 2, but all the numbers starting with 1 will work guaranteed no matter what. So really this question should be broken into cases, because these two cases behave completely differently. So you cannot try to take a shortcut and somehow compact these two scenarios into one and just try to get it through one working out. You cannot do that. You have to break the question into cases. So this illustrates another problem-solving strategy, and that is you should be trying to be aware of working out that's overcounting or overcounting or undercounting. So you're getting the wrong count, you're getting too much or too little. Okay, so this kind of sounds more like a mistake you should watch out for, and not so much a problem-solving strategy. But we'll see in later harder questions, right? This actually is a strategy. Like, we're gonna purposefully over or undercount the question on purpose, and then we're gonna look for ways to correct that undercount or overcount, and so that we can reach the correct answer. But this problem-solving strategy is usually used for like very tough questions, and we can get the proper solution for this particular one through another method. We don't need to utilize this particular one. So this is kind of looking ahead. Alright, so let's do D correctly now. We should break it into cases, right? So let's go with numbers that starts with 2. We're insisting on starting with 2, right? So there's only one option here. 2 is gone. We'll try to be less than 230, right? So our second digit itself must be 1, okay? Cannot be the other ones. So again, we only have one option here. So 1 is gone, it's used up. And now we're free to choose any of the 4 remaining ones. Okay, so that's this case done. Next one, we want to start with 1 strictly. So one option, we have to choose the 1. But you can see that as soon as a number that starts with 1, the rest can be whatever. This number overall would be guaranteed to be less than 230. So in your second slot, you got 5 available options, and then 4. Altogether, we have 24 numbers less than 230. Okay, and that's fine. That's doing this question through cases, getting the numbers across the 2 cases and adding them. But look, there's an even better strategy to get the answer to D rather quickly, actually. And to see that, just imagine all the possibilities there are from doing this experiment, okay? And if you look across all the possibilities, really, this is all of them. Like, if you look at any number that you could construct, the number is either more than 230, or it happens to be exactly the number 230 itself, or it's less than this 230, right? These are all the possible outcomes there are if you choose to just look at any possible number you can form. So this represents the totality, right? All the possibilities there are. You can think of this as one big equation, right? So first of all possibilities 120, that's just from the answering A. You can see that from this experiment because the digit 0 is not even available. You cannot construct 230, right? So yeah, there's zero amount of 230s. But more than 230, you can see that that's actually, we did this question, it was part C, right? And there are 96 numbers that's greater than 230. So you can see that what you're after can easily be discovered through a simple subtraction. You don't even need to work this out directly, right? Like, just look at this as an overall equation. You can see that if you want this term, all you gotta do is take the 120, the all possibilities, and subtract off this scenario. So what we want is the grand total minus more than 230, and there's 96 ways of doing that. And of course, we arrive at the same answer. Okay, so this illustrates another problem-solving strategy. Can you answer the question not directly, but can you use a subtraction trick to get at the answer? Okay, next question. Okay, let's go through it. So from what we're working with, we got 7 letters, and they are the 4 vowels. And words in quotes, it just means that it's really just a sequence of letters, right? They don't need to be actual sensical words. Okay, let's here are the final answers. Let's go through A. Alright, so we want the final word to contain exactly one vowel. I should maybe put the word exactly. So I want exactly one vowel to appear in the overall word. Okay, so, but you can see that, let's just focus on the vowel. We got 4 letters to build overall, but let's just focus on the vowel initially. And you can see that which vowel you're going to use to utilize in answering this question obviously matters, right? The word will be different if you elect to use different vowels, okay? So the first part of this answering this question, you should actually think about picking which vowel you want to use. There are 4 vowels available to us, right? So just pick a vowel that you want to use, and there are 4 ways of doing so. Next thing, you're going to take the vowel you've chosen, and you're going to allocate a spot to place that vowel, okay? That's an important thing you should consider, because where the vowel situates will constitute as different words, right? Like if it sits at different spots, that will build different words. So once you have chosen which vowel to use, now you're going to choose a place to put the vowel in, okay? And because there are 4 slots, 4 available locations, you can stick the vowel, and so there are 4 ways of doing this. Okay, so that's the vowel completely taken care of. So the remaining letters must be the consonants, right? And how many consonants do we have? We've got 3, okay? There are 3 slots and 3 consonants, so you have to make use of all of them. You don't have to choose from the consonants, you just have to put them in, okay? So now imagine you put your vowel maybe in this spot here. Okay, so these are your consonant spots. So now when you try to put the consonants in, you can see that really you're just taking 3 letters, right? And you're just jumbling them. So how many ways can you shove the remaining vowels in? Is nothing more than just 3 factorial, because you're just shuffling and rearranging the 3 consonants in the consonant slots, okay? So there are 3 factorial ways of doing so. Okay, so once you have the full working out, all the available options you worked out along the way, to produce the final answer, just multiply all of them together. And so there are 96 ways for doing A. Okay, next one, part B. We want to ensure the word has the letter X in it, but the Y doesn't appear. Okay, so just focus on the X first. So imagine you're holding the letter X, right? And you're trying to form a word. What do you have to do with the X? You have to place it, right? So again, where you places constitutes the different words. So the allocation, picking up the letter X and putting it in a spot is an option, right? And the word is completely blank initially, so you got 4 ways of placing the X in. Okay, so we used up the X, and the trick to deal with not Y is to actually just pick up the letter Y and just throw it away. Like just throw it away and don't even consider it for the rest of the experiment. That's the trick. That's how you deal with not having Y. Okay, so there are 7 options right in the beginning. X is gone because we placed it in. It's in there somewhere. Y is gone because we threw it away. So now there are only 5 available letters to work with. Okay. So there are 5 available letters, but there are only 3 remaining slots. So you can see that we have to do 5, pick 3. Okay, so from 5 available letters and pick 3 of them that we want to use. So altogether, the final answer will be 4 times this thing. Okay, so at this point, some people will ask this very good question. So before, maybe we look at the previous example. See how we have to sort of pick the letters and then allocate the spots for the letters. So some people look at this example and go, well, I picked up the letters. Why do I not have any more working out to sort of allocate the letters? Okay, and that's a good question. And the answer to that is basically the nature of permutations. Like when you do a permutation, right? What's intrinsic about it is that it already takes order into account. That's what makes a permutation. Permutation looks at ways of like going to 5 objects, picking 3 of them, and considering the number of ways of shuffling them in the different arrangements, right? So in that sense, a permutation already takes order into account. It already has that shuffling sort of built into it. So you don't need to sort of think about how those 3 letters are going to be arranged because the permutation itself has already taken care of that. Okay, so the multiplication of these 2 numbers gives us 240, and that's the answer for B. Okay, for C, in a sense, is a bit easier than B, because again, so now you want to ensure the word contains both X and Y. So just pick pick a location to place your letter X. There are 4 ways right in the beginning. Now X has already gone into a certain spot, so now you only got 3 more spots to allocate where the letter Y is going to go to. Okay, and that's it. So that's the letters X and Y taken care of. Now you got 2 more slots to fulfill, right? And out of your 7 letters, you used up 2, and there's 5 remaining ones that you can pick from. And so to allocate and fulfill that, you got 5p2 ways of doing so. Okay, and multiplying that together, 240. For D, I want all vowels. But there are only 4 vowels, right? And you want to form a 4-letter word, that means you have to use all the vowels. So really, this question is nothing more than just take all the vowels and shuffle them in all the various orders, right? So that's just rearranging and shuffling 4 objects. And that's 4 factorial ways of doing so. Okay, hopefully with E, you can hopefully you saw that as a subtraction trick question. That's problem solving strategy of using subtraction somehow, because this is how you should think about it. Again, think about all the possibilities. Here they all are. No matter which word you build, right? When you look at the final product, that word either has 0 consonants or it has 1, 2, or up to 3, because there are only maximum 3 consonants in this question, right? X, Y, and Z. So this is the total outcomes, right? This is all the possibilities there are. And look at the wording of the question, at least 1 consonant, right? So what exactly constitutes as at least 1 consonant? It's this. It's literally this, right? At least 1, so 1 or more. So this chunk here is what answers the question, at least 1 consonant. So just visualizing this equation, you can see that if you want this, right? If you want this, why would you do these 3 scenarios separately and do the hard work for that? That's a lot of work. You gotta do these all separately and add them all together. You don't have to work this out directly, right? Look at this as an overall equation. Like if you want this, what you can do is simply work this out, and then subtract them off. And naturally you'll arrive at this, okay? So all possibilities is, with no restrictions, there are 7 letters. We're gonna get 4 of them, so that's 7p4. And so that you can see that, again, going for that equation, at least 1, this bit, is equal to all possibilities minus off this bit. Okay, so minus the case of 0 consonants. But 0 consonants just means all vowels, right? So we don't even need to do any more work because all vowels was computed. It was 24 in part D. So the answer is nothing more than this. And turns out to be 816. Okay, so and here's the list of all the problem solving strategies we have seen so far.